Hello class, this is a video tutorial on Similarity Part 1. In this video, we'll be looking at scale factor. When it is known that two shapes are similar, we can calculate the scale factor. The scale factor is the number the side lengths of one shape have been multiplied by to obtain the other similar shape. I'll show you what I mean here. In this case, triangle ABC is similar to XYZ. So we're being told that these two shapes are similar. Now this is an example of an enlargement because we went from the smaller shape to the larger shape. Okay. To find the scale factor, we take a value from the larger. So let's say I take 6. So the scale factor, 6, and we're going to divide that by the corresponding side to 6. So 6 is opposite 55. Well, 55 is opposite 3. So those two sides are corresponding. So 6 divided by 3, or 6 over 3, you can use your calculator for that, but 6 divided by 3 is 2. So the scale factor for this is 2. Okay, so from the orange to the purple, it's been multiplied by 2. You can check this. 3 times 2 is 6. 5 times 2 is 10. 6 times 2 is 12. So all three sides of this triangle have been multiplied by 2. This is an example of an enlargement. Take a look here. We can do another one. We're being told that these two triangles are similar. So TUV is similar to triangle PQR. Once again, we're going from a large shape, from the orange, to a smaller shape in the purple. This is an example of contraction. So to find the scale factor here, let's just pick the smaller number. So let's just pick any number, well, any side length from this triangle here. I'm going to pick, let's pick 5 to make it easy. So let's go 5 over, or 5 divided by. Well, 5 is opposite the 90 degrees. Well, in this case, 25 is opposite the 90 degrees. So 5 over 25. You can use your calculator and check. 5 over 25 is 0.2. So this is a contraction by 0.2. I'll demonstrate to you what I mean here. You can calculate this. That means 25 times the scale factor of 0.2. It'll give us the corresponding length of the contracted shape. So 25 times 0.2 is equal to 5. 15 times 0.2, well, since 15 is opposite 40, 40 is 3. So take a look. 15 times our scale factor, we get that 3. And lastly, 20 is opposite 50. So 50 is opposite 4. But if you do 20 times 0.2, we get that length of 4. So this is what it means about the scale factor. It's what multiplies, so in this case we can say scale factor is equal to 0.2, is the number which we multiplied by from one shape to the other. Now in all of these, we could have easily switched them around and said we go from purple to orange. So if we went from purple to orange, that is a contraction because you went from large to small. In this case, large to small, that's from orange to purple. But if we went from purple to orange, that would be an enlargement. So it depends in the direction which you're doing the calculation. Okay, so let's go do a few examples of this. You can pause the video and calculate the scale factor of each pair of similar triangles. So here we go. So we have similar triangles here. 2x dot, so they are similar. So let's take a look. Just to keep things simple, let's always go from orange to purple. So we're starting here, going to purple. So because of that, let's always pick a number in purple. Let's go with 9. 9 divided by, well, 9 is opposite the dot. Well, the corresponding side of the dot is 6. So 9 over 6. Calculating that, so 9 over 6, that gives me 1.5. So the scale factor here is 1.5. That means 6 times 1.5 gives me 9. 5 times 1.5 will give me 7.5. And 4 times 1.5 is 6. So the purple shape is 1.5 times larger than the orange shape. Let's do another one here. You can pause it and give it a go yourself. For this, I'm just going to keep it nice and simple. Let's always go from orange to purple. That means let's pick a number from the purple. Let's pick 7. 7 is opposite the 90 degrees. So 90 degrees is opposite the 14. So 7 over 14. So 7 over 14 gives us 0.5. So that means the purple is 0.5 times the size of the orange. Another way you can say it is that purple is half the size of the orange triangle. Let's do another one. Here we go. You can remember, just to keep things simple, always go from purple to orange, which means we're going to pick a number from the purple. Let's pick 15. 15 over, well, if you take a look, if you put 15 over 3, it's not quite correct because it's a bit tricky to figure out which side is where. If you take a look, 5 is bigger than 3. Therefore, 15 is bigger than 9. So 15 is bigger than 9, and 5 is bigger than 3, which means 15 and 5 correspond to each other. So it needs to be 15 over 5. So 15 divided by or over 5 gives us 3. This means the purple triangle is 3 times bigger than the orange triangle. That is the scale factor there, 3. One last one here. This one's a little bit trickier. If you take a close look, 47 doesn't match anywhere here, but we have a 63 and a 70. If we were to try and calculate this missing side here, or this missing side, let's actually do that. Let's find this missing side first. In a triangle, all the angles must add up to, so 63 plus 70 plus, let's label this angle x. Every triangle must add up to 180 in the angles on the inside. 63 plus 70 is 133 plus x equals 180. Minusing 133 on both sides. So this cancels out the 133. X is equal to, so 180 minus 133 is 47. So that missing angle is actually 47, which means we can see that 47 is opposite 12, 47 is opposite 18. So keeping things simple, from orange to purple, so always picking a number from purple. 12 over 18, calculating that, 12 over 18 gives us 0.6 recurring, or 2 over 3. So that there is the scale factor. This means that the purple triangle is 2/3 the size of the orange triangle. So I hope that gave you an insight into the scale factor of similar triangles. Hope to see you in the next video. Best of luck.